Alright, so today what we'll be talking about is secant lines. And a secant line, we've kind of dealt with it a little bit, but a secant line is just a line that intersects the circle twice. Okay, now we've talked about chords, which are just segments that intersect a circle twice. Now we're going to extend those into lines. Okay, now if I continue to draw this, and if I draw off another one that looks like this, lo and behold, I made a actual inscribed angle. Okay, so just remember the inscribed angle is half of the intercepted arc. So we already know that part. Now what we're going to do is we're going to move around these secant lines and put, okay, if you notice the actual point, for the angle, the vertex is on the circle here. So this is on the circle. Okay, now we're going to talk about what happens if you put the vertex inside the circle and then outside the circle. And there's three different ways that it could actually happen outside the circle. Okay, so if it's inside the circle, now you would think, oh, it's just half of this. Well, if it depends on where I move it. Okay, and in actuality, it's actually half of the sum. So the measurement of angle E, well, this would be AEB or CED, okay, is actually equal to half, and you could use 0.5, it doesn't matter, half of arc AB plus arc DC. And voila, you're all set. You're all done. Okay? Alright, so basically all you need to do is add up these two these two arcs right here, and then divide them by 2 or multiply them by 1/2, and you get these two angles. And remember, you are going to be working with vertical angles, so those two angles are going to be the same. Okay, now over here. So once again, this one is just half. Okay, we don't do anything with the other parts, so it's half of this arc. Okay, this one is actually, when you move the vertex inside the circle, you're going to have to add up these two. What if it's outside? What you're going to have to do is you're going to have to do some subtraction, okay? And the subtraction are going to be the intercepted arcs. Okay, so for this one right here, all right, the measure of angle, and probably should put a letter on there. Let's put Z. Yeah, let's put, oops, capital Z. Okay, so the measurement of angle FZI, okay, this is actually going to be equal to 1/2 times arc FI minus arc GH. And here's a rule of thumb. You always want to go the bigger arc minus the smaller arc. Okay? That's always going to be just a really good rule of thumb. And the bigger arc is always on the opposite side. Okay? Now, probably we'll see a theme here with this. We're going to be dealing with the intercepted arcs right here. So the measurement of angle JKM is going to be equal to 1/2 times arc JM minus arc JL. Okay, now you're probably asking yourself, what about these arcs on the outside? We don't really care about those. Those are used to actually get this stuff, so just so you know. Okay, so here we go. Measurement of angle POQ is going to be equal to 1/2 of arc, and you're going to have to use the major arc, PRQ minus arc PQ. Okay? Alright? Alright, so this is some just really easy stuff. Now, just so you know, this is one of those ones where if I know this arc, but I don't know this arc, I just subtract to find this other arc right here, the major arc. I would just go 360 minus arc PQ. Okay, and that would actually be that arc right there. Okay, so here's some really cool things to draw away from this. Okay, on the circle is half of the intercepted arc. Okay, inside the circle, the vertex is what I'm talking about. Okay, if it's inside the circle, it's half of the sum of the two arcs, the two intercepted arcs. Okay, and if it's outside the circle, okay, so if it's outside the circle, it's going to be half of the difference of the two arcs. Okay, if you notice, that's a pretty common theme with all of them. So if it's outside, half of the subtraction. If it's inside, half of the addition. And if it's on, half of just the intercepted arc. Okay? All right, let's move on to actual segment lengths. All right, so now segment lengths don't have anything to do with angles, but they actually have some cool relationships. So A times B is going to be equal to C times D. That's that simple formula for this one right here. Now, is this set up like a proportion? Yes. Is it a proportion? Not exactly, but that's where the idea does come from. Okay, now on these ones, you do need to add up the entire lengths. Okay. So this one will be x plus w, and this one will be z plus y. Okay, just kind of deleted it. So x plus w, and you just need to add them up because that's how the formula actually works. So this be z plus y. Now on this one right here, when you're working with this one, you will actually just add up these two, and I'll show you how this one actually works. So this would be z plus y. Alright, so the formula is actually set up like this. The formula is actually going to be w times x plus w equals y times z plus y. Okay, just to give you some actual clarification on this, you take the outside segment times the sum, and that should equal the outside times the sum. Okay. Okay. Now on this one, if we carry the same idea over, sorry, let me get rid of this. Let's copy. There we go. If we carry that same idea out here, okay, so the outside times the sum, the right side is going to be pretty easy to see. It's going to be y times z plus y. Okay, let's get that times there. But the other side is going to be harder to see. It's actually going to be t times the totality, which is t. Okay? And that would just turn into a just simple, easy peasy. Let's go ahead and copy this. That would just turn into t squared. Okay, so that's where that idea actually comes from. Okay, now this one is the toughest one. I'm going to tell you right now, if the unknown variable is here, it's a lot easier. But if the unknown variable is, let's say, right here or right here, it is harder and harder to know. If it's the unknown variables in here, that's okay. So this is easy. This one's easy. Okay, and this one's easy. Alright, but if it's out here, this is definitely harder to solve because you're going to be dealing with a quadratic and you have to solve it quadratically. Okay. Put that one in there. There we go. Okay, so as you're working with this stuff, just take your time, use your formulas, and just remember it's just a simple multiplication. You just have to solve it, and you're all set, okay? All right, that's it for working with secant lines and segments. I'll talk to you later. Bye.